So now we're going to build a polynomial function where we give you the zeros. So we have a polynomial function f of degree 4, whose coefficients are real numbers and has the zeros -2, 2, and 3 minus I. So we've identified 3 of the 4 zeros. Our job is to first find the 4th zero. Because the polynomial function has real coefficients, that means that because 3 minus I is a 0, its conjugate, 3 plus I, is also a 0. So now I've identified all the zeros. Here's what's next. If f of r equals 0, then we know x minus r is a factor of f. So our function is going to be f of x equals some coefficient a, where a can't be 0, and I'll elaborate more on the role that a plays shortly. And then we'd simply write out all the factors of the function based on the zeros. So because -2 is a 0, x minus -2, or really x plus 2, is a factor. Because 2 is a 0, x minus 2 is a factor. This is where it's going to look a little weird, but because 3 minus I is a 0, x minus 3 minus I is a factor. And lastly, because 3 plus I is a 0, x minus 3 plus I is a 0. Okay, so that's a little bit like what we looked at back in the first section on polynomials, but now we have complex zeros in here. What role does a play in the polynomial? To help you see that, I'm going to go to my GeoGebra graphing tool. So all I did is put in the expanded, or the multiplied out form of the polynomial into GeoGebra. And what's nice is, even though I can't see a complete graph, I can see it crossing at -2 and crossing at +2. Those are the two real zeros. I have 2 non-real complex zeros as well. Those don't show up as x-intercepts in the graph. Okay, so there I have a graph, right? All I'm going to do down here is graph a different function. G of x equals 2 times f of x. And notice that all that happens is the graph stretches by a factor of 2. Or if I make this -2, it just causes the graph to reflect about the x-axis and then stretch by a factor of 2. And so my point in doing all that is this number a can be anything you want it to be, as long as it's not 0. It doesn't affect the zeros of the function. All it does is affect the stretching or reflection on the graph of the function. That's it.